Hi, and welcome to Solving for Polynomial Functions. Okay, let's get started. You might want to get comfortable because this one problem is probably going to take a super long time. So let's just get going. Okay, so the first thing you want to do is you want to actually change it into a problem that actually is able to be solved for x. So that means set it equal to 0, basically. So x to the third minus 2x squared minus 4x minus 55 equals 0. So now it's all set to be solved for 0. Okay, so there's a little step that you probably might want to do before you get started, which is to identify how many zeros we have for this function, or in other words, find how many answers of x we're going to have when we actually solve for x in a problem. Okay? And to do that, you have to identify what is called the degree. So your degree is going to be your biggest power. So what are my powers that we have in this problem? So we have power of 3, power of 2, power of 1, power of 0. So out of all those powers that I just mentioned, which number is the biggest? So I hope you said 3. So therefore we have degree 3, which means we have 3 zeros, and we have what is known as 3 answers. Okay, so when we finally find all the answers for x in this problem, one of my 3 answers is going to be a 5. Okay, and how do I know that? Well, they gave it to us right here, that x equals 5. Okay, do you think they're always going to give us, or we're always going to give you guys that first answer? For now we will, to get you guys used to the process. But eventually when you guys start taking higher math courses, then they're not going to give you that first answer. And that's when you're going to have to figure out on your own what that first answer actually is. But we'll be nice for now. Okay, so here's how you actually find and do, or here's what you actually do with this first answer of 5. So this 5 is going to help break apart this polynomial function that has power of 3, or degree 3, into a quadratic function with degree 2. Okay, and that's what that 5 is going to do. It's going to help us turn this polynomial function into a quadratic. Okay, so we're going to use a process called synthetic division. So here's how you set up synthetic division. First, you get that first answer that works, the 5 that they gave us. You put it in a backwards L. Okay, that's the first thing you do. The second thing you do is you're going to write all the coefficients from your polynomial function. So basically grab all the numbers in front of the x's. Okay, so what number is in front of this x? A 1. What number is in front of this x? -2. What number is in front of this x? -4. And what number is all the way at the end? -55. Okay, so basically you just set up synthetic division. Okay, so to actually carry out synthetic division, it's really easy. And ironically, you're not even going to be doing any division at all. All you're going to do is add and multiply. So let's do this. Okay, so first thing, let's add 1 and the number right underneath. Yeah, right underneath it basically. So 1 plus blank, or 1 plus nothing, is 1. Okay, then you're going to multiply next. So the number 1 that we just got as the answer of 1 plus nothing, we're going to multiply that 1 to your backwards L number of 5. So what is 1 times 5? 5. And that answer you're going to put right underneath the -2 in the next column. And then you're going to start round 2 of adding and multiplying. So what is -2 plus 5? 3. And what is 3 times 5? 15. Okay, where'd that line pop out of? Let's erase it. Okay, so let's start round 3. Let's add. We got 11. Let's multiply. Positive 55. Okay. And because you know 5 is actually an answer, here's what advantage that serves us. Okay, whenever you know you're using an actual answer of the problem in synthetic division, you're always going to get a 0 in this last column. So if you ever don't get a 0, yeah, like if we ever get like a 5 or a 3 or a 2 or a -6 or a number not 0 in this last column, that means you did synthetic division wrong. So just go back and do it again because you made a mistake with either adding or multiplying. Okay, or maybe you wrote a sign wrong. Yeah, it's one of those reasons basically though. Okay. So now that we have the synthetic division process done, let's put back the x's that we took away when we set this problem up in the first place. Yeah, so we took away x to the third, we took away x squared, we took away x, and we took away x to the 0. So when I start putting back the x's, I want to start with the last x that I took away, which is x to the 0. So let's put that one back first. And then we took away x to the first power after that, or before that rather, and x squared before that. So what does this do? This basically tells us that, yeah, synthetic division did its job. And what was the job? To turn that polynomial function with degree 3 into a quadratic degree 2. Okay, because now we have way more options available to us to solve for x, right? We can do factoring, which actually we can't because there's no two numbers that make 11 when I multiply and 3 when I add, right? 1 and 11 make 11 when I multiply, but make 12 when you add, so that doesn't work. Complete the square might work, but that would involve cutting this 3 in half and squaring it, and that's going to be an ugly fraction, so we don't want to go anywhere near that. So our last option is to go to quad formula. Yeah, and luckily we just did that in a previous lesson, so it still should be kind of fresh in our brains. Yeah, and if you easily forget the formula, like I recommended in the previous video, just keep on writing the formula every single time you have to do a quad formula problem. So that's what I'm doing right now. I practice what I preach. Okay. All right, and then we have to plug in numbers for a, b, and c. So your a value is going to be the number in front of x squared, so that's a 1. Your b value is going to be the number in front of regular plain old x, so that's 3. And your c value is going to be the one all the way at the end by itself, so that's 11. Okay, so let's start plugging in these numbers. And by the way, oh, I almost forgot. Synthetic division, that's done. Okay, everything in that box there, that's synthetic division. Synthetic division, if you couldn't hear what I said, yeah? So now let's do quad formula. Let's plug in 1, 3, and 11. So x equals negative b, which is 3, over 2a, so that's 2 times 1, plus or minus b squared, so that's going to be 3 times 3, minus 4 times a times c, which is 11, all over 2a, so that's 2 times 1. Okay, so let's simplify some of these things. So negative on the outside still yet, and 3 over 2 for our first fraction, plus or minus. And then we have 9 minus 44 all over 2. Okay, so let's keep on going. So we got x equals negative 3 over 2 plus or minus square root negative 35 over 2. Okay, so before we continue on with that, let's simplify this square root negative 35. So we're going to put that on the side here. So square root negative 35. And then hopefully you remember that conversion, right? I squared equals negative 1. So when I start breaking up this negative 35 into little pieces so I can see if anything gets circled, yeah, I'm going to turn the negative sign into an II. I'm going to turn the 35 into a 5 and a 7. And then I'm going to circle things that match. Yeah, so these letters match, so I'm going to circle them. Do any numbers match? No. The 5 and the 7, they don't match with each other, so they don't get circled. So the only thing that's allowed to go outside the square root symbol is an I. And since the 5 and 7 don't get circled, they just get put back together again, and you get 35. So this is going to very soon replace that right there. So let me extend this page so that I can write a little bit more. So we're going to replace this square root of negative 35 with I35. Okay, so let's do that. So x equals, oops, let's actually change it back to the other color. So x equals negative 3 over 2 plus or minus I root 35 over 2. Yeah, and we just found our last two answers, and you're saying, how is this two answers? Well, we got a plus and a minus here, right? So we have negative 3 over 2 plus this, and negative 3 over 2 minus that. So that's actually 3 answers total. So when you write your final answer that identifies the 3 answers for x that we just found, you have your first answer 5 that they just gave us in the beginning of the problem, and then you have your other 2 answers, right? Negative 3 over 2 plus or minus, And maybe I didn't make the braces big enough, so let me just erase this last one and put it at the end when I'm all done writing my answer. Then I don't have to squish nothing in. So I root 35 over 2. And there's our 3 answers. Yeah, 3 answers, 3 zeros, or you want to call it that. That's fine with me too. Okay, all right. Thank you for joining me, and good luck on this lesson.